Welcome to Chapter 11. In this chapter we look at how you can test, debug, and monitor Qt applications. And specifically we're looking at how we can do this within the context of Qt Creator. And it may sound like that's limiting, but actually if you explore it you'll discover there's a lot of things you can do within Qt Creator. So with that, let's sort of take a look at how things run. Okay, we're going to start out looking at the big project. We want to analyze this. So I've selected the project. Notice it's bold. I'm going to go up here to Analyze, select Clang Tidy and Lazy. I'm going to make sure this is not selected. The file's outside the base directory. There's only one file. It's actually the generated code that's created from our state machine XML. So we only want to analyze these, and we've told we want to build the project before we analyze. And so I'm going to click Analyze, and there's nothing on the application, but if you look here we actually see the project being compiled. The reason you might want to build the application first is you get a little bit more information out of it. And it looks like we're almost done. Now, if I look at the application window down here, you'll see we're actually analyzing all the CPP files. It takes a little bit of time, but it's good time to spend. On many projects where I have set up continuous integration, one of the steps we actually do is to run static analysis on the code. That's in addition to doing testing on the code. So when we get done with the CI build, we actually have static analysis results and testing results. All right, almost done. As you can see here, as it's analyzing, we're starting to see warnings. The warnings are little triangles. At this point the code has been cleaned up a fair amount. I tend to code in such a way to reduce this. When I say I tend to code in such a way to reduce this, you will find I actually turn on the options that actually does some of the analysis while I'm actually entering the code. All right. Well, that's working. Let's go take a look at some of the things we found. All right, the parameter active states is copied for each invocation, but only used as a const. Actually, I believe if we looked at the whole thing, there we go. The parameter active states is copied for each invocation, but only used as a const reference. Consider making a const reference. All right. So little things like that. We'll talk about those a little bit more as we look at how, in Chapter 13, as we look at how we can speed up our Qt applications. But if I want to look at the code, where that is, I can click over here. It takes me right to the code, and I can see, oh, there's an opportunity there. I'm not going to fix it this time, because that's really the next chapter. Here's another warning. It's warning me, let's take a look at this one, that we're converting from a double to an int, a narrowing conversion they call it. As you can see, my in-code stack analysis, my real-time typing, it actually comes up, says implicit conversion turns floating into integer. Again. So what you want to look for, and it's already gone through everything, is you want to look for little things with red error marks. There are none, so we're pretty good. You can also, if you want, select something and have it fix it by clicking over here. I will be quite honest, it's a great idea. There are some cases, and as of the recording of this in the beginning of July of 2019, there are some cases where the fix actually causes errors in the code. So I'd be very leery and very check it before I just use the automatic fix-its. All right, having done that, let's move into testing our code. So we're going to start out with Qtest. In the book, I talk about static analysis being sort of a test. It's actually part of the validation, or actually more correctly, the verification of the software. But there is nothing to replace actual testing of the software also. So let's set this as the active project. That's our Qtester code. Again, this is in the repository. And what we're going to do, we're going to have to go Tools, Tests. We're going to run all tests. And wow, those ran really quick. They ran really quick because all we're really testing is the state transitions between heating, cooling, fan only, fan off. Now, interesting enough, there's a little warning arrow here, so let's dive into it. I'm just clicking on these here to expand them. All right. Like you saw in the testing, or like you saw in the analysis window, and the compiler window when you look at things, or the issues window, I should say, we have a warning. This is a simple warning message. And we have a file here. I'll double click that. And so it's on this line here. And you can see, well, yes, we actually manually generated a Q warning. Makes sense. It's pretty straightforward. And gives us a chance to actually look at the tests again. Notice here is our data block. And we actually have simple slots we use for testing. So this is a sample test, first one run. And then we have our data, and we test the states. All right. Now I also claimed, and I will show you in a second, that you can test with Google Test. So first here, let's get rid of these. Let's go over to this project, set it as the active project. Now, I need to make sure I can compile this. So I'm going to go and build it. Okay, it built without problems. Now I wanted to show you something in here, and this is a really important thing, and it's the way we installed Google Test. So I'm going to open up the Google Test dependency. Notice in here, in the code on the repository, it uses tilde, but this path here has to be set correctly. And this file does not recognize tilde. So I had to actually manually edit that. It brings you up a warning. Actually, an error will be shown in the compile window if it's wrong. Let me show you what happens if you don't change that. So this is how the file came. And let me show you what happens if I try to build it now. We'll save it. And I gotta go over to my compile window. Some of the required modules couldn't be found. So again, remember when you go and actually try to run this, make sure you point exactly where the file is, and then it'll build fine. All right, so that built fine. There's just a couple warning messages, but it built fine. If it doesn't build correctly, when you go to run tests, you won't have this menu. They'll all be grayed out. So we're going to now go and we've got it building correct. We're going to run all of our tests. These are the same tests written in Google Test. This code is available in the repository. It shows you how to lay out the Google tests. The documentation on Google tests is incredible. And my test results. Alright, this one ran 10 tests. Do you see how I did that? I clicked down here on test results to bring them up. And it says sample test passed. And all of these passed. Again, there's one for each condition. Now I'm just going to show you the code for Google Test really quick. Again, double click on the line, takes you where it is. Alright. Our sample test, expect that 1 equals 1. Expect equals 1, 1. Assert that 0 is equal to 1. Alright. And our second test, very similar. We have a test that's going to take data, we define the data, and then we instantiate the test case, which works over the data. The data is just stored in a Qt container. Or actually can be stored in any standard container, because it really is not written specifically for Qt, but is well supported in Qt Creator. So, moving on. We're going to go back to Big Project. And I wanted to show you about how you can pause debugging. And more importantly, what you can actually see in the debugger. So, I'm running all this stuff on the host because it's a little bit easier and it's not really paramount that you see it on the target. Alright, my window expand a little bit. And I can close this up, close this up, close that up, and close actually everything up. What I'm going to do is I'm going to pause here. Now what I really wanted to show you, you're like, what is this? This is some random place in the code. What I really wanted to talk about is show you some of the things here. If I click here, I only have one thread running. Interesting. Let's go a little bit farther. Now we're starting. That's why main window wasn't up. Sorry about that. Now, main window has started running. I'm going to pause it. And we actually stopped on this line of, it looks like, yeah, this is actually Qt code. Since we have the source, we can see it. But if I pull down threads here, look at all of these threads. We have our network access monitor. Remember, we're doing network API calls. We have our QML display thread. We have our file info thread. We have our debugger thread. We have another QML running thread. Remember, we have 2 QQuick windows running. Our data bus connection, our dbus connection, and our main project. So, if I go in, let's see what's one I want to pick. Nah, actually, we'll skip that for now. I will go into sources, temperature chart. Actually, let's do history form. And we'll put a breakpoint. Let it go. Wow, we hit it immediately. We're still in thread 1. Here is our list of everything that's called. You can see there's a lot of stuff that happens behind the scenes. So, all right, I wanted to show you some of the more advanced things we can step over. We can step into. You can actually see the constructor for QStand item being executed. don't really want to go and learn all that, so I am going to step out of. I'm going to step out of this method. All right. This allows me to restart the debugging session, restart the program. So we can do instruction-wise at the assembler level, or we can do source-wise. So anyways, I wanted to show you that so you can see how you can work with the debugger. We've done a little bit of this before. You can dive in to like our time. No, we can't access those. Or dive into our timestamp. It took a second because I had to actually read everything and interpret it correctly. So, all right. Well, let's stop doing that for now. And I'm going to close this up, this up, this up, this up. Clean up a little bit. Go back to the edit view. Now, the next thing I wanted to look at was logging. We talked about different ways to log things using Qdebug, Qwarn, and a few others. So let's open up our logging example code. All right. Again, I've set the organization to Packt, and I've set the application name to logging examples, and our message pattern to that really long string, which I really like because it gives me a lot of detail. So this is going to go fairly quickly when I run it, because it's not much code. So let me run that. Oh. Yep, you're right. I forgot to set logging example as the active project. Run it. And there we are. Let me make that a little bit bigger. Let's look at how it compares to our code. This is a debug message. And if you remember from this statement here, debugs start with a D, warning messages are flagged with a W, informational messages are flagged with an I, a critical message is flagged with a C, and a fatal message is there. And notice the program ended here. We never printed, we never get here because we had a fatal error. It stopped the application right there. All right. We do a little cleanup here. Close that project. We'll close this one. Close this project. And we'll close this project. So that leaves us with the last part of this chapter, which is using Valgrind. So the first thing, let's look at our code. This is just a piece of code to use as much processor power as possible and be as slow as possible. So I'm going to go up here. I'm going to click Analyze. And the first thing I want to do is I want to do a function profile of it. Alright, it says I'm trying to run it on debug mode. Usually you want to do it when you build for compile. Let me click no here. Let me not start that. If you look down here, we have debug and release. We also have profile. Profile creates the same code as release, except with full debugging information. Debug creates slower code so you can actually look at things more in depth. So since we did it with the debug code in the chapter, I'll do it the same here. Feel free to experiment and see how it changes if you do it with the profile or the release version. So yes, I do want to do that there. And it's going to run the code. As you can see, we're printing out our results as it runs. I will close this window because we don't really care about the results. We just care about that we did the work. And here, we've got a lot of information. First thing I want to point out is we find that 81.4% of the overall time of this program was spent in this not fib. That 98.7% was spent in main. That includes the time in not fib. It makes sense. That's the only thing the code does is goes into main and invokes not fib a lot. Though it is a little bit interesting to find out when you look at that, that there is, what is that? Roughly 17% of time spent in main. So it has to be handling the constructor here and this stuff here. A little hint, if I moved this out of here, with outside this loop, I think it would be faster because I wouldn't be reconstructing it each time. But with this in here, this is being run 1,000 times. Actually, I got a second. Let's do that. All right. I can go here, and we'll analyze it again. Yes. Save it. Give it a second. I don't know, does that look faster as it scrolls across the screen? Felt faster. Yeah, actually we saved a little bit less than I expected. We saved, what was it, 81 before, and we're at 82%. So we saved 1%. Okay. Anyway, down here we can actually see a graph. Let me see if I can find. Actually, let's expand this up. I can see all of the things we entered. There's main. I can click on that and we can actually notice how it dives in. Main called not fib, and here's how much it's spent. Alright. So there's a lot of information here. It's really good for tracking down things. And one of the things I encourage people to do, because I do a little mentoring at work, a lot of mentoring work. It's very tempting when you write code to spend all of your time trying to make it as fast as possible. But really what you want to do is write the code so it works, then do profiling on it and find out where your problems are. Don't waste time trying to perfect the speed of the code until you actually have the code working and you know it's worth changing something. So as we just saw, moving that line did very little. We weren't spending a lot of time. This points out another difference also. All we know is how long it took this function. We had no way of knowing how long it took to do this line. All right, let's go look at memory usage. So that's the other part of Valgrind. So we're going to run it on the memory. Now this runs a bit slower, sort of, because it's looking at where we allocate and deallocate memory. And we don't do that much. Everything's on the stack. Memcheck passed. Let's try something else. I am going to open up Big Project quickly. And I'm going to set that as the active project. I'm going to close this main so we don't get confused. Let's run the function profiler on this. I suggest you do this on your own in the book, and so let me just demonstrate what happens. There we go. Had to go to the application output. It is slow. I will warn you about that. Valgrind can be slow. And we'll do a couple of things here. Let's look at our settings window. I just clicked. So when I say it is slow, you understand what I mean. It's slow because it's actually recording information about everything that happens. I clicked. Click. Click. That's not too bad now. Let's look at the history. And let's resize this. All right. Okay. So we have a little bit of data. I'm now going to close this window. And in a second, you can see here it's finishing gathering information. Now, just for fun, let's lower that, raise this up. And you can actually see self-cost is how much it costs to run the method. And look at function names. Most of these function names I don't recognize. These are mostly things, well, I recognize them, they're not code we wrote. Which I guess is good for us. Right. I can sort it by number of times it was called. So this method, low-level user lib x86, was called 47,000 times. All right. I can see how about inclusive cost. Again, internal libraries, there's our main. Click on it. We can say 96% of the time is spent in main. Makes sense because we come in main and we start running right here. Main window. Main window took 43% of the time. It means there's a lot of other work happening, which you can see down here. All right. It is kind of interesting as you go through this. Actually, notice we have main window selected. Let me do that again. We can see the cost here of the various calls. We're spending a lot of time handling data. A lot of time on qvariance, array data, newing up information. And we can see how much time was spent in main. Let's dive down in weather fetcher. We can see how much happened in weather fetcher. Again, this is really good stuff as you're trying to find out where your code is working. Now the other thing I said to do is let's look at the Valgrind memory analyzer. we're going to do again on big project. Yes, we know that. Look at the application output. Here's the actual function call to start it. Call valgrind on our project. Again, it's a little bit slow starting up. Valgrind slows things down because it intercepts everything in its own libraries and tries to monitor it. One of the things I will actually mention here while we're waiting, the longer you let both of these run, the more information you get about your code. We spend a lot of time starting up. We're actually going to probably spend more time starting up than running the code. So it's really more important to see how our code runs and functions that we give it a longer time running. All right. We'll play with resizing. We'll look at our settings. I've clicked already. All right. Let's turn that down a little bit. Just clicked. Clicked. Who uses Kelvin? I will use Celsius. And then let's turn on our MQT broker. All right, look at history. And we'll actually stop the program. And now we can actually see what memory issues it found. So it says we have we lost a bunch of records in temperature storage, and that's code we wrote there. So what it looks like, let me get a little more screen real estate here, is that there's a problem. We allocate the memory here. We then set the query. And where do we ever deallocate it? So what we can do is you can double click on this. Or actually, let's do it simple. Single click, find usages. We care about the CPP file. And there's the problem. We knew it up. We set the query. And we know another query here, but we never release it. So I'll leave that as an exercise to you, but that demonstrates what happens when you do the memory check. It's great for finding those little things. And on an embedded program, it's really important. If your program's going to run for days, maybe even months or years, little memory leaks like that become big things. All right, well, thank you for joining me for Chapter 11, and I look forward to seeing you in Chapter 12.